The sun breaks through the morning fog at Stonehenge, casting long shadows from the ancient monoliths across the dewy grass. For thousands of years, these massive stones have stood in their mysterious arrangement, silent sentinels guarding secrets we are only beginning to understand. What if I told you that everything we thought we knew about this prehistoric monument was about to change forever? 3 weeks ago, an artificial intelligence system analyzing ground-penetrating radar data made a discovery that left archaeologists speechless. The AI identified a pattern so subtle, so perfectly aligned with astronomical events, that human researchers had overlooked it for centuries. Not just any pattern, but a countdown that appears to have begun. My name is Warren Quincy, and I have spent the last 15 years studying archaeoastronomy, the ancient science of how prehistoric cultures tracked the heavens. But nothing in my career prepared me for what I am about to show you. The evidence suggests that the builders of Stonehenge encoded a precise timing mechanism into their structure, one that measures far more than solstices and equinoxes, one that appears to be counting down to something specific. The question that haunts me, that has kept me awake for 21 nights straight, is simple. What happens when the countdown ends? And more urgently, why is it suddenly accelerating? The implications reach far beyond archaeology. Physicists, astronomers, and mathematicians are now racing to understand what the builders of Stonehenge might have known about cosmic cycles that we are only rediscovering today. What you are about to learn challenges everything we thought we understood about prehistoric knowledge and humanity's place in the cosmos. This is not a story about aliens or supernatural forces. This is a story about human ingenuity across millennia, about patterns hidden in plain sight, and about the most sophisticated ancient timekeeping device ever discovered. A device that appears to be counting down to a celestial event that occurs only once every 26,000 years. And according to our calculations, we are in the final phase. Stonehenge has always been more than just a circle of stones. For centuries, we have known it tracked the summer solstice. But what if that was merely the most obvious function of a much more sophisticated instrument? What if those massive sarsen stones and precise bluestones were arranged to measure something far more significant? The first hint came in 2020 when Dr. Elizabeth Orwell's team from Cambridge University deployed advanced ground-penetrating radar across the Stonehenge landscape. We were expecting to find maybe some additional post holes or buried stones, Dr. Orwell explained during our first interview in her cluttered office overlooking the River Cam. Instead, we found what appeared to be concentric rings of magnetic anomalies that extended far beyond the visible monument. The data was so complex that Dr. Orwell's team spent 2 years trying to make sense of it. The breakthrough came only when they fed the raw data into a new machine learning algorithm designed to detect subtle patterns in archaeological datasets. At first, we thought the AI had made an error, she said, pushing her wire-rimmed glasses up her nose. It identified what appeared to be a mathematical sequence encoded in the positioning of not just the visible stones, but in subsurface features no one could possibly have seen without modern technology. The sequence appeared to be counting down intervals related to astronomical cycles. When I first heard this, I was skeptical. After all, the builders of Stonehenge worked with primitive tools around 5,000 years ago. How could they possibly encode complex mathematical formulas into stone arrangements? And why would they create a countdown? To understand this mystery, we need to step back and examine what we already knew about Stonehenge before this discovery. The monument's basic astronomical alignments have been understood since the 1960s, when astronomer Gerald Hawkins used an early computer to confirm that Stonehenge aligned with solar and lunar positions. The main axis of the monument aligns with the midsummer sunrise and midwinter sunset. Certain stone arrangements mark the extreme positions of the moon. These alignments were impressive enough. They demonstrated that Neolithic people possessed sophisticated astronomical knowledge and the ability to encode that knowledge into architecture. But the newly discovered patterns suggest something far more profound was happening at Stonehenge. The AI identified what we now call temporal markers, specific points in the monument that correspond to astronomical events occurring over vastly different timescales, explained Dr. Marcus Chen, an astrophysicist who joined Dr. Orwell's team after the initial discovery. Some markers track events that occur annually, others track events with cycles of hundreds, or even thousands of years. The most significant of these markers appear to track the precession of the equinoxes, a 25,920-year cycle caused by Earth's axial wobble that slowly shifts our view of the stars. This phenomenon causes the position of the equinox sun to move gradually backward through the zodiac constellations, completing a full circuit approximately every 26,000 years. Modern astronomers have known about precession since it was explained by Isaac Newton in the 17th century. But the idea that Neolithic people understood and tracked this phenomenon seemed implausible until now. The positioning of certain bluestones, combined with subtle angles in the Sarsen circle, creates a kind of three-dimensional star map that shifts its astronomical alignment annually, Dr. Chen explained. But the truly mind-blowing aspect is that these alignments are not static. They're designed to track changing stellar positions over thousands of years. In other words, Stonehenge appears to function as a giant astronomical computer, one programmed to track vast cosmic cycles and potentially alert its users when certain celestial configurations occur. But why would ancient people invest such extraordinary effort into tracking these long-term astronomical cycles? What were they counting down to? This question led our investigation in an unexpected direction, toward the field of archaeoastronomy and its most controversial theories. Dr. Thomas Reynolds, a leading archaeoastronomer from University College London, has spent decades studying how ancient cultures around the world tracked astronomical phenomena. Almost every major ancient civilization showed intense interest in tracking precession. He told me during a rainy afternoon interview in his book-lined office. The Maya, the ancient Egyptians, the builders of Göbekli Tepe in Turkey, they all created monuments and myths that appear to reference this 26,000-year cycle. Reynolds believes that ancient peoples recognize something modern science has only recently begun to appreciate, that Earth experiences regular cycles of climatic and possibly even magnetic changes that correspond roughly to precessional periods. Ice core samples and other paleoclimatic data suggest Earth experiences major climatic shifts approximately every 13,000 years, or half a precessional cycle, Reynolds explained. The end of the last ice age, the flooding of the Black Sea, the climate shifts that contributed to the collapse of various Bronze Age civilizations. All these events appear to correlate with specific points in the precessional cycle. Could the builders of Stonehenge have been creating a monumental timer designed to track these cycles and warn future generations about impending changes? The evidence uncovered by Dr. Orwell's team increasingly suggests this possibility. But there was another discovery that transformed our understanding of Stonehenge from fascinating to urgent. When the AI analyzed subtle magnetic anomalies detected beneath the Stonehenge landscape, it found evidence of what appears to be a previously unknown system of concentric rings, made not from stone but from magnetized earth. These magnetic rings create a pattern that changes in intensity based on fluctuations in Earth's magnetic field. Dr. Janet Rivera, a geophysicist specializing in archaeomagnetism, explained the significance. Earth's magnetic field isn't constant. It fluctuates in strength and has even reversed polarity many times in Earth's history. What's remarkable about the magnetic features at Stonehenge is that they appear designed to respond differently to varying field strengths. In effect, the magnetic rings function as a type of geomagnetic barometer, with different sections activating as Earth's magnetic field changes. Most intriguingly, measurements taken over the past decade show that these magnetic signatures have been changing at an accelerating rate, precisely as Earth's magnetic field has been weakening. Earth's magnetic field has decreased in strength by about 10% since the 19th century, Rivera explained. But the rate of decrease has been accelerating in recent decades. If the trend continues, it could eventually lead to a geomagnetic excursion or even a complete pole reversal. A geomagnetic pole reversal, where Earth's north and south magnetic poles essentially flip positions, is a regular occurrence in geological history, happening every 200,000 to 300,000 years on average. The last full reversal occurred approximately 780,000 years ago, which means we're statistically overdue. Modern civilization has never experienced such an event, but its consequences could be profound. A weakened magnetic field during the transition period would reduce our planet's protection from cosmic radiation, potentially affecting everything from climate to satellite communications to power grids. Here is where the mystery deepens. The magnetic rings at Stonehenge appear to be counting down to something, with the countdown accelerating in perfect correlation with the actual measured weakening of Earth's magnetic field. It's as if the builders created a system specifically designed to alert future civilizations to an impending geomagnetic event, Rivera said. But how could they possibly have known about these cycles thousands of years ago? The answer may lie in what happened the last time Earth experienced major geomagnetic changes. Approximately 12,000 years ago, roughly half a precessional cycle, Earth was emerging from the last ice age. This period, known as the Younger Dryas, saw dramatic and rapid climate shifts that transformed the planet. Recent studies of ice cores and lake sediments from this period reveal evidence of geomagnetic excursions, short-term changes in Earth's magnetic field that coincided with these climatic shifts. If previous civilizations witnessed the effects of these geomagnetic changes, they might have recognized patterns connecting celestial configurations with terrestrial events, Dr. Reynolds suggested. Stonehenge may represent their attempt to encode this knowledge for future generations. This theory gained unexpected support from another field entirely, mythology. Dr. Emily Wilson, a comparative mythologist at Oxford University, has identified recurring themes in ancient myths worldwide that appear to describe celestial phenomena associated with precessional changes. Myths about world ages, cosmic destructions and rebirths, or gods battling in the sky appear across disconnected cultures, Wilson explained. When you analyze the astronomical references in these myths, they often describe the same celestial configurations associated with specific points in the precessional cycle. The myths frequently describe a time of transition between world ages marked by floods, fires, or other cataclysms, followed by a renewal. Intriguingly, many of these myths place our current era at the end of such a cycle. What's particularly interesting about Stonehenge, Wilson continued, is that British and Celtic myths associate the site with timekeeping and prophecy. The legends of Merlin bringing the stones from Ireland specifically mention their power to mark great cycles of time. These mythological connections might be dismissed as coincidence, except for one unsettling fact. When Dr. Orwell's team calculated the endpoint of the apparent countdown encoded in Stonehenge's structures, it aligned precisely with a rare astronomical configuration set to occur within our lifetime. The countdown appears to target a specific alignment involving the galactic center, the precessional position of Earth, and several outer planets, Dr. Chen explained. This alignment occurs only once every complete precessional cycle, approximately every 26,000 years. According to their calculations, this alignment will reach its peak in 2046, just over 2 decades from now. What makes this timeline particularly concerning is that it coincides with projections from the British Geological Survey and other scientific bodies monitoring Earth's weakening magnetic field. If current trends continue, Earth could experience a significant geomagnetic event, possibly even the beginning stages of a pole reversal within the same time frame. The correlation is either the most remarkable coincidence in archaeological history or evidence that the builders of Stonehenge possessed knowledge we're only beginning to rediscover, Dr. Orwell concluded. But how could Neolithic people possibly have possessed such sophisticated understanding of astronomical and geophysical phenomena? This question led us to reconsider the timeline of Stonehenge itself. The traditional narrative holds that Stonehenge was constructed in phases between approximately 3000 BCE and 1600 BCE. However, recent excavations and dating techniques have complicated this timeline. Some features of the landscape appear to be significantly older, possibly dating back to the end of the last ice age, approximately 10,000 BCE. Dr. Samantha Parker, a geoarchaeologist who has conducted extensive studies of the soil beneath Stonehenge, found evidence suggesting human modification of the landscape began much earlier than previously thought. We've identified soil disturbances and carbon deposits that date back to approximately 10,500 BCE, she explained. This coincides with the end of the Younger Dryas period, a time of dramatic climate change. This timing is significant because it places the earliest activity at Stonehenge near the beginning of the current precessional half-cycle. If the site was indeed designed as a countdown timer for geomagnetic and astronomical events, it would make sense for its creation to begin shortly after the previous major cycle transition. Furthermore, Recent DNA analysis of human remains from the region suggests a more complex picture of the people who built Stonehenge. Rather than being the work of a simple agrarian society, the monument may have been created by the descendants of highly specialized hunter-gatherer groups who survived the dramatic climate shifts at the end of the last ice age. These people would have had direct experience of rapid climate change and its consequences, Dr. Parker noted. They would have had strong motivation to track long-term cycles that might predict future changes. But even accepting that Neolithic people might have recognized these patterns, how could they have created such a sophisticated astronomical instrument? The answer appears to lie in a combination of observational astronomy, oral tradition, and mathematical knowledge that was more advanced than we've previously given them credit for. Dr. Robert Miller, a mathematician who specializes in ancient number systems, has identified evidence of sophisticated mathematical concepts embedded in Stonehenge's design. The number of stones, their spacing, and the proportions of various features incorporate mathematical relationships that reflect astronomical ratios, he explained. These aren't crude approximations. They're precise calculations that would require centuries of astronomical observation. Miller believes the builders of Stonehenge developed a mathematical system specifically designed for astronomical prediction. They weren't doing mathematics as an abstract exercise, he said. They were creating a practical tool for tracking cosmic cycles with direct relevance to their survival. This utilitarian approach to astronomy might explain why the knowledge encoded in Stonehenge wasn't preserved in written form. It wasn't theoretical knowledge but practical technology, like a farmer's almanac writ large in stone. Think of Stonehenge not as a temple but as a calendar, clock, and warning system combined, suggested Dr. Orwell. Its primary purpose wasn't worship but prediction, giving its users advance notice of cosmic events with terrestrial consequences. This view of Stonehenge as functional technology rather than ceremonial architecture has gained support as researchers have discovered increasingly precise astronomical alignments within the monument. But the AI's analysis has revealed something even more remarkable. Evidence that the builders anticipated how these alignments would change over thousands of years. Certain features of Stonehenge only come into astronomical alignment thousands of years after its construction, explained Dr. Chun. It's as if the builders created a device program to track changes across millennia and reveal new information at specific points in time. This long-term design explains why the countdown aspect of Stonehenge remained hidden for so long. It was designed to become increasingly apparent as Earth approached the target date, like an alarm clock with a gradually loudening ring. The magnetic anomalies we're detecting are becoming more pronounced as Earth's magnetic field weakens, confirmed Dr. Rivera. Features that would have been barely detectable a century ago are now clearly visible with the right equipment. But perhaps the most compelling evidence for Stonehenge as a countdown timer came when Dr. Orwell's team discovered what appears to be a literal counting system encoded in the monument's design. Using the AI to analyze subtle patterns in the positioning of stones and buried features, they identified what appears to be a base 12 counting system that tracks precessional movement. Each unit in this system represents approximately 72 years, the time it takes for the precessional position to shift by 1 degree. The system appears designed to count down 360 units of 72 years each, for a total of 25,920 years, or one complete precessional cycle, Dr. Miller explained. Based on our analysis of current astronomical alignments, the countdown has approximately 25 units remaining, corresponding to the period between now and 2046. This time frame aligns disturbingly well with current scientific projections regarding Earth's magnetic field. According to data from the European Space Agency's Swarm satellite constellation, which has been monitoring Earth's magnetic field since 2013, the field is weakening at an accelerating rate, particularly in a region stretching from Africa to South America known as the South Atlantic Anomaly. If current trends continue, Earth could experience significant geomagnetic instability within the next 2 to 3 decades, confirmed Dr. Maria Santos of the European Space Agency. While we can't predict exactly what form this will take, the possibilities range from increased auroral activity at lower latitudes to temporary shield weakening that could impact satellite operations and power grids. More concerning are the potential climate implications. Some research suggests connections between geomagnetic events and short-term climate fluctuations, possibly due to changes in cosmic ray penetration affecting cloud formation and atmospheric chemistry. We're not talking about catastrophic climate collapse, Dr. Santos emphasized. But even moderate shifts could impact agricultural regions already stressed by ongoing climate change. This convergence of archaeological countdown and scientific prediction raises an uncomfortable question. What should we do with this information? Is Stonehenge warning us of an impending crisis? And if so, how should we prepare? Dr. Orwell's team has been cautious about drawing definitive conclusions. We're still in the early stages of understanding what the monument is telling us, she stressed. What's clear is that Stonehenge represents an extraordinary example of long-term thinking, an attempt by one civilization to communicate important information across thousands of years. The most remarkable aspect of this discovery is not just that ancient people may have understood astronomical cycles we're only now rediscovering, but that they cared enough about the fate of future generations to encode this knowledge in stone. Whatever happens in 2046, the builders of Stonehenge have already achieved something remarkable, reflected Dr. Reynolds. They've succeeded in transmitting information across 5,000 years, a time span that dwarfs all of recorded history. This long-term perspective offers an important lesson for our own civilization, which often struggles to plan beyond the next fiscal quarter, let alone the next millennium. The builders of Stonehenge created a monument designed to function for tens of thousands of years, an expression of intergenerational responsibility almost unimaginable today. As our research team continued investigating the countdown encoded in Stonehenge, we discovered another layer of complexity that deepened the mystery. The AI analysis revealed that the monument doesn't just track one cosmic cycle, but the intersection of several, including the 26,000-year precessional cycle, the 41,000-year cycle of Earth's axial tilt variations, and the 100,000-year cycle of orbital eccentricity. What's extraordinary is that these overlapping cycles create periodic nodes, where their effects align, explained Dr. Chan. The countdown appears targeted to one such node, a rare configuration where multiple astronomical cycles reach significant points simultaneously. The rarity of such alignments might explain the extraordinary effort invested in Stonehenge. If these alignments correlate with geophysical changes on Earth, they would represent critical transition points that occur only once every several tens of thousands of years. But this raised an even more provocative question. If the builders of Stonehenge understood these cycles, did they experience the previous alignment node? And if so, what occurred during that period that made them so determined to warn future generations? To answer this question, we needed to look back approximately 26,000 years, to the height of the last ice age and the period immediately preceding the dramatic climate shifts of the Younger Dryas. Dr. Parker's team analyzed ice cores, lake sediments, and other paleoclimatic records from this period and found evidence of significant geomagnetic excursions coinciding with rapid climate fluctuations. The paleomagnetic record shows several short-term field-weakening events between 26,000 and 13,000 years ago, she explained. These events correlate with climate oscillations recorded in Greenland ice cores. If human populations of that era witnessed these changes, they would have experienced them as a series of dramatic and relatively rapid shifts in their environment, shifts that would have demanded adaptation or migration. Intriguingly, this period also saw significant changes in human cultural development. The Upper Paleolithic period witnessed an explosion of sophisticated cave art, complex toolmaking, and evidence of increasingly abstract thinking, developments that some anthropologists believe reflect cognitive adaptations to challenging and rapidly changing environments. There's growing evidence that dramatic climate shifts drive human innovation, noted Dr. Jason Howard, an evolutionary anthropologist. Periods of environmental stress select for enhanced planning abilities, technological innovation, and symbolic thinking. Precisely the cognitive skills that would be necessary to conceptualize and construct something like Stonehenge. This evolutionary perspective suggests a provocative possibility. What if Stonehenge represents not just a warning system but a cognitive adaptation? A way for humans to extend their thinking across timescales far beyond an individual lifespan. Most humans struggle to think beyond a few decades, Dr. Howard explained. But survival in a world with long-term cycles that can impact climate requires multigenerational thinking. Monuments like Stonehenge might represent an external cognitive tool, a way to extend human thinking across centuries and millennia. This theory gained support from comparative studies of other ancient sites worldwide. Dr. Wilson identified at least 7 other prehistoric monuments that appear to encode similar astronomical alignments related to precessional cycles, including Göbekli Tepe in Turkey, dated to approximately 9600 BCE, the Nabta Playa stone circle in Egypt, circa 7000 BCE, and certain features of the Great Pyramid complex at Giza. What's remarkable is that these sites were constructed by cultures separated by vast distances and time periods, yet they encode similar astronomical knowledge, Wilson noted. This suggests independent discovery of the same patterns likely driven by observations of real celestial and terrestrial events. These parallels strengthen the case that Stonehenge's countdown feature reflects actual observed phenomena rather than arbitrary cultural constructs. But they also deepen the mystery of how this knowledge was developed and maintained across thousands of years without writing. We're dealing with a form of knowledge transmission fundamentally different from our own, Dr. Reynolds suggested. Rather than written texts, these cultures used landscape and stone as their medium, creating physical structures that directly encode relationships through their alignments and proportions. This architectural approach to knowledge preservation has proven remarkably durable. While written texts can be destroyed, misinterpreted, or lost to language changes, astronomical alignments embedded in massive stone structures remain functional for millennia. Stonehenge has succeeded in preserving and transmitting information across time spans that no paper document could hope to match. As we continued our investigation, another pattern emerged that shifted our understanding of Stonehenge's purpose. The AI analysis revealed that the monument appears designed not just to count down to a single future event, but to track recurring patterns across multiple precessional cycles. The structure incorporates features that would only come into alignment during specific configurations that recur approximately every 26,000 years, Dr. Chun explained. It's as if the builders were creating a cyclical calendar spanning tens of thousands of years. This multi-cycle design suggested something profound about the builders' intentions. They weren't just warning about an impending event in our time. They were creating a system to track these cycles indefinitely into the future, far beyond their own lifetimes or even the expected duration of their culture. They were thinking on timescales we struggle to comprehend, reflected Dr. Orwell. Not decades or centuries, but tens of thousands of years. They were creating an inheritance for countless future generations of humans they would never meet. This long-term thinking becomes even more remarkable when we consider the practical challenges involved in constructing Stonehenge. The monument's sarsen stones weigh up to 30 tons each and were transported over 20 miles from their source. The smaller blue stones, weighing up to 4 tons each, came from the Preseli Hills in Wales, approximately 140 miles away. Recent research suggests these massive stones were moved using a combination of sledges, rollers, and boat transportation, requiring extraordinary coordination among hundreds or thousands of individuals. The precision placement of these stones, creating alignments accurate to within fractions of a degree, required sophisticated planning and astronomical knowledge. The labor investment alone is staggering, noted archaeological engineer Dr. William Foster. We estimate it would have taken over 1.5 million person-hours to complete Stonehenge in its final form. That represents an enormous commitment from a population that was simultaneously engaged in agriculture and basic survival. This extraordinary effort makes sense only if the builders believed they were creating something of vital importance, not just for themselves but for countless future generations. The monument represents one of the most dramatic examples of long-term thinking and intergenerational responsibility in human history. As our research team grappled with the implications of Stonehenge's countdown feature, we realized we needed to better understand what might happen when the countdown reaches its conclusion in 2046. This required integrating knowledge from multiple scientific disciplines, from astrophysics to geomagnetism to climatology. The emerging picture suggests we may be approaching a period of increased geophysical instability, driven by the convergence of several astronomical and terrestrial cycles. The weakening of Earth's magnetic field, currently accelerating at an unprecedented rate, appears to be the most immediate manifestation of these converging cycles. The geomagnetic field doesn't just protect us from cosmic radiation, explained Dr. Rivera. It also plays a role in stabilizing the movement of jet streams, ocean currents, and other systems that influence weather patterns. A significant weakening or temporary reorganization of the field could disrupt these systems. While a complete magnetic pole reversal would unfold over centuries or millennia, even the early stages of such a process could have significant impacts. Satellite systems, power grids, and electronic infrastructure could experience increased disruption. Navigation systems reliant on magnetic compasses would require recalibration. Wildlife that uses magnetic fields for migration, from birds to sea turtles to certain mammals, might experience disorientation. More concerning are the potential climate implications. Recent research suggests connections between geomagnetic events and regional climate fluctuations. A 2021 study published in Science identified correlations between past geomagnetic excursions and significant shifts in tropical rainfall patterns, potentially linked to changes in cosmic ray flux affecting cloud formation. We're not talking about a doomsday scenario, Dr. Santos emphasized. But we could be facing a period of increased climate volatility, coming at a time when our climate systems are already stressed by anthropogenic warming. This context gives Stonehenge's countdown new significance. If the builders indeed experienced similar geophysical events during previous cycle nodes, they might have been trying to warn future generations about a period of environmental instability requiring preparation and adaptation. The message isn't "the world is ending," suggested Dr. Reynolds. It's more likely prepare for a transition period requiring adaptation and resilience. This interpretation aligns with recurring themes in ancient myths worldwide, which often describe cyclical periods of disruption followed by renewal and reorganization. Rather than prophesying apocalypse, these traditions typically frame cosmic transitions as challenging but survivable shifts requiring preparation and adaptation. As we continued analyzing the data, we discovered evidence suggesting the builders of Stonehenge may have encoded not just a warning but potential solutions. The AI identified patterns in the positioning of certain features that appear to correspond to seasonal rainfall patterns and agricultural cycles calibrated to different climate regimes. Certain stone alignments appear designed to track optimal planting times under varying climate conditions, explained Dr. Parker. It's as if the builders were creating an agricultural manual for adapting to different climate states. This practical dimension reinforces the view of Stonehenge as functional technology rather than purely ceremonial architecture. The monument appears designed to help its users navigate both short-term seasonal cycles and long-term climate transitions, providing practical guidance for survival during periods of environmental change. This perspective offers valuable insights for our own time. As we face accelerating climate change and potential geomagnetic disruption, the builders of Stonehenge remind us that humanity has navigated significant environmental transitions before. Their monument stands as testimony to both the challenges of such transitions and the human capacity to observe patterns, plan across generations, and create technologies for adaptation. Whatever happens in 2046, Stonehenge has already delivered its most important message, reflected Dr. Orwell. It shows us that humans are capable of thinking and planning across vast timescales, of caring about the welfare of generations thousands of years in the future. This message of intergenerational responsibility has profound implications for our current environmental challenges. If Neolithic people with limited technology could create systems designed to function across millennia, what might we accomplish with our vastly greater resources and scientific understanding? As we face our own period of environmental transition, Stonehenge offers both warning and inspiration. It warns us of potential challenges ahead while inspiring us with evidence of human foresight and care extending across thousands of years. In the years since our initial discovery of Stonehenge's countdown feature, scientific monitoring of Earth's magnetic field has confirmed the trends that initially concerned us. The European Space Agency's SWARM mission has documented continued weakening of the field, particularly in the South Atlantic anomaly region, where field strength has decreased by over 30% in the past century. Concurrently, astronomical observations have confirmed we are indeed approaching the rare alignment of celestial cycles that appears to be the target of Stonehenge's countdown. The precessional position of Earth relative to the galactic center, combined with specific planetary alignments, is moving toward the configuration encoded in the monument's design. These converging lines of evidence have transformed what began as an archaeological curiosity into an urgent scientific investigation. Research teams worldwide are now monitoring geophysical indicators, developing models to predict potential impacts of geomagnetic change, and creating strategies for protecting vulnerable infrastructure. We're not just passive observers of this countdown, Dr. Santos emphasized. Understanding these cycles gives us the opportunity to prepare, to create systems resilient to the changes that may be coming. This proactive approach represents perhaps the most fitting response to the message encoded in Stonehenge. The builders didn't just warn about future challenges. They created practical tools for navigating them. By following their example, combining long-term thinking with practical action, we honor their extraordinary legacy of intergenerational care. As the countdown continues, Stonehenge has become more than an archaeological site. It has emerged as a symbol of human foresight and responsibility, a reminder that we are capable of thinking and acting on timescales far beyond our individual lives. The mysterious circle of stones standing on Salisbury Plain for 5 millennia has delivered its message just when we needed it most. As we face environmental challenges requiring long-term thinking and collective action, Stonehenge stands as proof that humans are capable of exactly this kind of extended foresight and care. The countdown encoded in its ancient stones isn't a harbinger of doom but a call to attention, reminding us to look up from our immediate concerns and consider the longer cycles that shape our world. In doing so, we reconnect with a tradition of astronomical observation and environmental adaptation that stretches back to the dawn of civilization. Perhaps this is Stonehenge's ultimate purpose, not just to track celestial cycles but to remind us of our place within them, to help us understand that we exist within vast patterns of time that extend far beyond our individual lives, yet which we can comprehend, track, and prepare for through careful observation and intergenerational cooperation. As we stand before these ancient stones, watching the shadows move across their weathered surfaces just as countless generations have done before us, we become part of something greater than ourselves, a human conversation across time about our place in the cosmos and our responsibility to future generations. The countdown continues, but thanks to the extraordinary foresight of Stonehenge's builders, we approach whatever lies ahead with eyes open and minds prepared, ready not just to witness the next great turning of cosmic cycles, but to navigate it with the same wisdom and foresight shown by those who raised these stones 5,000 years ago. In the shadow of Stonehenge, we rediscover our capacity for wonder, for pattern recognition, and for care extending across millennia. Precisely the qualities we need to face the challenges of our time and create a legacy worthy of those ancient builders who once looked at the same stars and considered the welfare of generations they would never meet.